And what about you? And in the garage today we have a 2010 Honda CRV, and this one has the 2.2 iDTEC common rail diesel engine. And the customer complaint is it runs like a pig and it's hard to start. Now, it's not really that smoky, but it absolutely stinks. Now, when it did come in here, there was the engine management light was on, so we did a quick scan because there's going to be something if the management light's on. So 2 faults in the engine. Cylinder 4 misfire, cylinder 4 mixfire, and battery voltage. And we'll just have a wee look in the OBD. So generic OBD scan, same thing. So have a wee look at the live data here on the snap-on here. Let me see. Cylinder 4 misfire counter, yeah, 70. Cylinder 2, 0. Cylinder 1, cylinder 3, 0. So it's just having a wee look through it here. See if there's anything I don't like a look of. Let me see. Injectors. So correction value for 1 is -3. Injector 3 is 3. Let me see, where's the other ones? Yeah, there we go. Injector 2 is also -3, and injector 4 is +3. So we'll have injector 1 -3, injector 2 -3, injector 3 +3, and injector 4 +3 as well. So what that is, it's, you know, the ECU is trying to put more fuel in it. So what happens is that, you know, say for example if your injector was blocked or something, you know, and there wasn't as much diesel go in, so it'll try and increase the quantity. So this quantity that is displayed is adding fuel. Now I don't know about these Hondas. These are piezo injectors in this vehicle, and I don't know about the Hondas for sure, the specifications of that, but I know on the Toyotas with piezo injectors it sort of maxes out at 5, and plus or minus 3 can be kind of normal, but that's like its maximum limit where you would want it to be, you know. But the very fact that 2 of them here are doing something different to the other 2, if that makes sense, you know. Look at the wee rev here. Yeah, still stuck at 3. That doesn't change. Yeah, so we'll do a wee visual around the engine, and I've had a wee look at DPRF stuff, and looks okay with back pressures and stuff. So that's piezo energies and voltages, all seem to be reasonably similar, and these sort of target and actuals here that I'm looking at, yeah, they all seem to be pretty, none jumps out at me anyway, you know. MAF reading seems a bit low. for a 2.2 diesel. Apart from that, real pressure 28,000 kPa. Okay, we'll have a wee visual. So the owner of this vehicle, he says he's owned this car for about 6 months, and all he's ever done, he says, is put a new battery in it, and he doesn't really know, you know, when it was last serviced or what was done or whatever, because he hasn't owned it that long, and he doesn't use it that much either. It's not an everyday use car, and I think it's been sitting a while as well, judging by the debris around it and stuff. So there's a couple of things you could maybe look at. So I'm keeping in mind those correction quantity values, you know. So we could do a leak off test on the injectors. Handy enough done. The injectors are at the top here. So, and just to see if that correlates, if the leak off correlates, and if there's anything that sort of jumps out at me. So there's no code. It's just a cylinder 4 misfire code in this thing. That's all we know, and it stinks. So it's not smoky as such, but it absolutely stinks. So that would indicate to me there's some sort of fueling issue or whatever it is. The other thing about these things is the fuel filter is away down there, and you know, they don't get changed very often because they're hard to do and they're inaccessible. The other thing as well, which I'm thinking about, is there's a common failure item on these iDTECs. There's an EGR pipe that runs around the head, you know, and there's a flexi bit in the middle, just roughly about the middle there, and it's way down there. You can't see it, it's buried, like, and they have a habit of fracturing, and you could maybe look down there with a torch and see if there's black soot or whatever it is, you know, on top of the bell housing or on top of the gearbox or something. However, I did say that the MAF reading, so the MAF reading from here was kind of low at idle, but that could be okay, because the EGRs on diesels will open at idle, and that'll lower the, you know, your air intake value then, the air intake mass. So that would tell me that that pipe then isn't fractured. But what I'm thinking of doing is, if you suspect a fueling issue, you know, the cheap and the easy thing to do is change a fuel filter, rule that out. We could do a leak off test, and what that will do is look at our quantities, see if there's anything that sort of jumps out at us or whatever. But what that will also do is let us look at the diesel to see if, you know, there's maybe been a misfueling event, see if it's cloudy, see if it's flammable, see if there's petrol in it, you know, that type of thing. So we can get an inspection on the actual fuel that's going into the vehicle. What did they say was the real pressure? 28,000. Well, that's about 280 bar. So rule of thumb, you need about 250 for the thing to even start. So it could be a wee bit on the low side, but you know, it's okay. But you know, anyway, I think I'll do a leak off test to see if any of the injectors are just leaking off mad or something. I don't really expect them to, because the ECU for 3 and 4, according to that data, is actually trying to add fuel. So I'm not expecting much, but we'll have it allows us to get a wee look at the diesel, and then we'll take this apart. Having a wee look at the air filter will give us an idea of the, you know, the service. If it's, you know, the air filter might be blocked, and that's just all it is. But we'll see. We'll do the leak off test first. Right, so that was after about 5 minutes, and well, they're all about equal. You just get a better view of that here now. This is cylinder 1, cylinder 2, cylinder 3, cylinder 4. So if I remember from our correction values, cylinder 1, cylinder 2, what was that? It was -3 with those two, but it was +3 with these. There's not a great difference here, but I can certainly see these two are different from these two, you know. So I'm trying to hold that as level as I can here. You know, so yeah, so we're getting misfires on cylinder 4. The engine management light has returned, and the code is still the same, cylinder 4 misfire, which is that one there. Very similar to the 3, but a wee bit different from that. But you know, it's not a great deal of difference in these injectors, you know. But yeah, I think we'll do a couple of things. We'll change the fuel filter and have a wee look, and take it from there. So just for completeness, what I'm going to do here is a flash test, or a flame test, or whatever you want to call it. So I've taken because we'll have samples of the diesel, I've put it into a metal container and I've covered it. So what we're looking for here is to see basically, is there been petrol put in with this diesel? And the reason why I don't suspect that that's the case here, because there's no real petrol-y smell from the diesel. However, because the car stinks, the smell from the exhaust fumes is bad. What that reminds me of, and this is just for maybe sort of future, this is just for reference. I had a car one time that was misfueled, but the punter didn't know that it was misfueled. So in other words, somebody had put petrol in the diesel. And that sometimes happens when you're in a situation with a customer, the guy that brought the car here, this Honda, he doesn't actually drive it. You know, it's the wife or the girlfriend or somebody else drives it. So he you know, he's no knowledge if he maybe didn't put the last fuel in it or whatever. So that was the case. And in the one that I had that was misfueled, but the person didn't know about it, the telltale sign was the fumes. Whenever I put that car into this garage, the fumes would cut the eyes out of you. That's the best way to describe it. Yeah, your eyes were streaming with the fumes of that thing, and that's even with all the doors open and all that there. And that was a sure, well, it's not a sure sign, but it's an indicative of a misfueling event. The cardboard here is the sample's up to here, but the cardboard here is for a couple of reasons. If there is petrol in here, the fumes off the petrol, I'm trying to trap them in the air that's left here. And then if it does ignite, it's easy to put it out, because the last thing you want is liquid, on fire, and if that spills, and it's in a metal container, because you don't want to use a plastic one in case it does ignite. So we just quite simply, and this is just a very basic test here. Flash test. Nothing. So if there was petrol in that, the petrol fumes would be in this cavity here, and all you would need to do is just wave that past it, and it'll flash over, So just a quick test, just for completeness. Yeah, so just to clarify a few points of my thinking, it's just, first off, you may have noticed perhaps that there appeared to be a wee bit more in the bottles whenever I brought it onto the bench, and that was because that was what the fuel was in the pipes. I held the fuel pipes up and allowed it to dump into them. But you can sort of tell right away, and I ran that car for about 5 minutes, because I was actually more interested maybe in getting a fuel sample, because once I started the engine, I could tell there was none of them leaking off excessively. So sort of what you're looking for is, you can see when it goes up the pipes. That's why we use clear pipes. So you can see whenever the fuel goes up the pipes, it sort of pulses. It sort of goes doot 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 doot. You know, if it's a sort of steady stream, if it's just streaming into it, you know, you've got a bad injector right away. You know, as I say, the fuel isn't going into the cylinder. It's just getting dumped back out again, or leaked back. That's why they call it leak back or leak off. You know, but regarding the correction values, I have some information here I'll share here, but as I said earlier on, it's for a Toyota. Whether this Honda here behind me is using that same strategy or same specification, that's the question that I have to remain, you know, unanswered in the back of my mind. I don't know, but this is what I'm going on just for the moment. So this is from Lexus or Toyota. This is OE information, and this is their specification. This is off a car that has piezo injectors, and this is the values that they're quoting, you know. So they call it a feedback value, you know. It looks like the other ones calls it a correction quantity, but it is a quantity. It's measured in it's measured by volume, so millimeter cube by per stroke. But the main thing is normal value -3 to +3. Normal, you know. So basically what's going on here is, when there is a problem with the operation of an injector assembly due to foreign matter in the inside of the injector assembly, the fuel injection volume decreases. As a result, the ECM gives instruction to increase the fuel injection volume, which causes the injection feedback value to increase. So a plus is adding fuel, minus sort of taking fuel away, you know what I mean? So the ECM controls the system, so the sum of the injection feedback value for all the cylinders is approximately 0. So for all the cylinders, it's trying to, you know, make equilibrium, you know what I mean? So even if the value of injection feedback is cylinder less than -3, it says here -3 is the lowest normal value. As long as the value of injection feedback value of those cylinders is 3 or less, the injector assemblies are not malfunctioning. So that's why I'm sort of I'm thinking here, I don't have, you know, from that test there and from these type of values, I don't have basically any evidence here at all of what's wrong with this car. So this is like a case study where you would get maybe get a fault code P0304, and this would be the typical sort of values. And this is large leak detected. So this is you can hardly read it, but basically it's stating here 5. You know, so these are different engine RPMs, the different rail pressures, and so it's showing 5, and that created that DTC P0304. So injection feedback value for cylinder 3 is 5, which is large. Normal value indicates the injector of cylinder 3 may be malfunctioning. In this case, foreign matter in the fuel is stuck inside an injector. Apologies, light went off there. Where was I? Foreign matter in the fuel is stuck inside the injector, causing the injector to malfunction. In order to remove the foreign matter in the fuel, the major cause of the problem, the fuel filter case needs to be cleaned, fuel filter needs to be replaced. So those values there, you can hardly maybe read them. Yeah, that's a bit clear there. So it shows feedback value -1, -2.5, 5 on cylinder 3, -1.8. And that's at 754 RPM. So it's increased here, 1478. And the rail pressure goes up in this case to 50 kPa, 50,000 kPa. And then when the large leak's detected, it drops, it falls off. So it's trying to compensate for the, you know, an excessive leak back, you know. So that's what I'm looking for in these values when I'm looking at those data pads, you know. And that's the sort of strategy that I'm going on. But as I say, I have to state, this is from Lexus, which is Toyota, and this will probably have, this engine will be running on more than likely Denso injectors, because like Toyota owns 25% or something like that of Denso. But anyway, more than likely. So there's the values there. In this case, in this example, minus 1.1, 2.5, minus 2.5, 5, and minus 1.8. So that's what I'm looking for here. I'm looking for something that's over and above. But according to this, the minus D plus 3 is nominal. So what's that say? When there's a major problem with the operation of injector assembly due to foreign matter inside the injector, the fuel injection volume decreases. As a result, the ECM gives instruction to increase the fuel injection volume, which causes the injection feedback value to increase. So there we go. So that's a bit of an explanation for that. But as I say, I still have to keep in mind that this is for the wrong car. Oh yes, I forgot to mention voltages, the piezo energizing voltages according to the data pads, they were all over 100 volts, so they're like showing 124 volts or something like that. Energizing voltage in the piezo, 100 odd volts. So the guys would normally test a piezo stack at 100 volts, so they put 100 volts through it to see if it can maintain the 100 volts. And according to these data pads that I can see, they're all, you know, the voltage wise, the piezo is fine. Filter of this, wee bit blank on that side. But yeah, as if we look in here, so that's the fuel filter down in there. And judged by the amount of cobwebs about the place, I don't think anybody's been in here in a while. And yeah, just on a note, what have we got? We have a Bosch CP4 pump. So yeah, I think I mentioned earlier on, there's an EGR pipe and it's buried away in here, and it's a habit of fracturing at the flexi. So while we're in here, we might take a wee look at that with a borescope. Right, so there's that. This is absolutely buried, this thing. So that flexi is the EGR pipe that wraps around the head, and that has a habit of cracking at that joint. And it actually looks pretty good. It nearly looks as if it's been replaced. That. Right, so we got our fuel filter cap off, and it was tight. It was really stuck tight, and I'm not too sure whether this has ever been changed. I think there's 122,000 miles in this. It's 2010 model year, and it's not going to come up on camera because the diesel is going to reflect the light, but I think there's a lot of sediment in the bottom of that, you know. And this is the filter that came out of it. Right, so let's see now. Not really any markings on it. What does that say? OBM. But I think this is original. But anyway, if we look in here, I'd say that's pretty block. It is completely covered in muck. Right, I've sucked a lot of that diesel out, and I'll just think, well, we'll have the bar scope out. I'll just stick it in there. So that's that housing. If I can get this right. That's what it looks like in the bottom of it. So just try and clean that out best I can. So we'll have our housing here cleaned out. Now, if you do one of these or whatever, there is actually a drain off way down the bottom. You know, it looks like a bleed nipple type of thing. You know, it's way down there, and you can actually, you know, drain it out. So there's a water sensor at the bottom of this, you know, when we float, and there is actually a drain at the bottom, but it's miles below, so it's easier for me just to suck it out. So anyway, we're going to fill this up with not diesel, but diesel purge liquid moly. So on some cars, I would run this through injectors and stuff like that. The setup in this scenario isn't really, you know, it's not easy to, wouldn't be easy to pipe it up. But what I'm going to do is put a lot of this into that housing. So when we first start it up, it's going to run on this here. It'll soon, you know, the diesel from the main tank will soon make its way into that. But that's what it's going to get at first start up. Right, so that's us all back together again. So we'll have a new fuel filter, the canister housing is cleaned out, and a new air filter, and all put back together again. So there we go, 122,000 miles, engine management light on, and on this one, there's no primer ball, so you can hear the pump in the tank, you know, priming whenever you turn the key a few times, and that should be grand. But I just want to have a wee look at the data here, and we'll get started up, see if there's any difference. So there's the codes. Misfire detected. That's all it's telling us. So we'll get rid of them first of all. So code's being cleared there. Management light is out. Right, so first of all in the data, it's under 4 misfire, which was, I think it was maxed out the last time I looked at it. I think it was throwing 70. Nothing there. So code's been cleared. Obviously the battery's been disconnected and reconnected, and but nothing as yet. And I can tell, actually, I can tell right away, you know, this thing's running an awful lot sweeter, and it doesn't stink as well. So we'll have a wee look at some other data here. Right, the real pressure is still about the same. Still 20, well, it's a wee bit higher. It was 28, I think it was last time. 28,000. It was 29,000. At idle. 30. So much the same, but slight improvement maybe. So our injection quantities, correction quantities, it's still the same. But I'm not saying that's wrong. You know, I know, as I said before, I know on the Toyotas, plus and minus 3 is acceptable. Plus 3 to minus 3 is sort of acceptable. Whenever it goes to like 5 or something, you know, you have a blockage in the injector or something like that. So they're still the same. It may take maybe a wee bit of learning, but I can tell that this thing is running a lot sweeter. So the customer described this when he first came in as, you would think it was off a cylinder, you know, and yes, it was showing on the data the misfire counter, So it's been running for a couple of minutes now, so let's see. The misfire counter was telling me. We still have it. It's up to 88. So that's not a fix. But it definitely is running a little bit better. Definitely is running better. We'll take it for a test drive and see. Well, bad news. Took it for quite an extended test drive, really got it up to temperature and took it up a hill, put it under load, you know, and going up through the gears, she quit, you know. So misfiring it crazy, basically only on 3 cylinders, you know, wouldn't go up the hill. So I had to stop, put my hazards on, reversed her down and got her into a laneway, turned around, down the hill, you know, run fine, cleared. On the flat here, back to here, grand, you know. So under a bit of load, it starts calving, as they say. So yeah, no management light on. So yeah, we'll have to see what we're going to do now. Yeah, we'll have a misfire counter on 1 cylinder, cylinder 4. So there's a couple of things going through my head here. You know, what's the best approach? So it's all pointing towards this injector, because, you know, if it was an EGR issue, if it was a general fuel supply issue, you know, you would think that would affect other ones, but it's only on this cylinder 4. It's counting misfires. But the only thing that's putting doubt in my mind, and this is the thing, and there's a wee doubt that starts creeping in, is despite doing a couple, I ended up doing another leak off test, you know, at a different temperature. And despite doing that, they all came out, there's nothing really, there's no smoking gun here, you know. There's no test that I can do really that says, yes, that you need to change that injector. Leak off test, it's not, you know, what we're looking to see is there excessive leak off or leak back in one of the injectors, you know, so the fuel isn't going into the cylinder, it's just getting dumped back into the tank, you know. So that's what we're looking for, and there's nothing really there to say that. The only other test you can do is an electrical test on these, which is, you know, you put a bit of voltage on it. You can do a resistance check as well on these piezo injectors. But I'm happy enough because most of the time, nearly all the time, this car's running okay. And that fact then also rules out a mechanical issue with this cylinder. So, you know, say there was low compression in this cylinder, or there was a valve unseating or something like that, you know, that would be there all the time then, you know. So this is intermittent. So it's only under sort of certain conditions. And I think, well, it's a combination of temperature and loading, you know. So the car basically runs in is going on the 3 cylinders because it appears according to the misfire data, but that's the only thing that I have, that on the fault code. And the fault code hasn't reappeared, but I can see it on the misfire counter that it's still not liking this one here, this cylinder 4. And yeah, so I happened to be chatting to Peter Kennedy on the phone about something completely different, and not about cars at all, about a wee meetup we're having and stuff. And I happened to mention, you know, what would be your next step? And he says, well, you need to talk to the customer, and you need to say, right, it's looking like you have a bad injector, but in my opinion, what I normally do is you take all 4 injectors out and you get them tested in a diesel specialist shop who, you know, simulates the conditions, and you can look at the spray pattern and all that old jazz. That's something that we can't do in a garage, you know, so we need to send them away or take them up to a guy that I use anyway. And when I do that, you take all four out. You know, I don't think there's a point in just checking the one. He might condemn the two according to the correction values now. The correction values are showing me that it's high on 3 and 4. So it's having to correct quite a bit on 3 and 4, which is +3. And these are in the minus numbers, you know, so but even that, to me, it's not really good enough, but it's telling me that, you know, be worthwhile getting the injectors checked. But the only thing, and again, this is the thing, when it's not your own car, this is where these sort of problems arise, is these injectors are very fragile. So you could actually break them, taking them out. So another thing that Peter mentioned was, well, you know, you could do a swap agnostics. You know, if your misfire counter is showing 4, then, you know, pull it and another one out and swap them over. Like the way you would do with a coil pack, and see if that counter, you know, shifts to another cylinder. But yeah, that's okay. But I said to myself, you know, if you're in there and you're taking all this stuff apart and all, again, you might as well just take all 4 out and get them tested independently off the car, you know, and then whatever that result is, you know, you act on that. However, I have a slight reluctance because in removing these injectors, I'll tell you why. These piezo injectors, so you can tell a piezo from a solenoid usually, because a solenoid, the leak back or the leak off, you know, usually comes out the top, you know, and on piezos, you know, it comes out the side. So at the top of the thing is the piezo crystal, you know, and that means the leak off has to come out somewhere else. Solenoids, usually the leak back pipe comes out the top, you know. So in these here, as you can see, the high pressure is connected on the top here, you know, but the leak back's on the side. But the sort of issue I have, if these are stuck in, you can't really get a wiggle on them, you know, you would do side to side, because you can't get the clamp out. So when you remove the clamp nut, this here, this stud remains in place, and so the clamp sort of has to come up with the injector. So the only thing you can do then is attach an adapter and a slide hammer or whatever it is onto the threads at the top here, and the only way is up, and you have to pull it up to get the clamp to clear the stud, you know. So what I'm saying is, if these injectors are stuck, you know, the risk is damaging the injectors on extraction while it's taking them out, and you're going to need X amount of injectors anyway then. So again, it's the customer's call of whether he wants to go down that road. And what we ended up saying was, well, you know, I could start stripping these lines off and taking these nuts off and see if these are, you know, loose, or see if they're going to move or whatever it is. Could go down that road, but it looks like that's the next step. But again, these things are pretty fragile. You know, even taking this nut off here, you could just wing that, you know, and bend that or snap it or whatever. But it's the fact that you can't sort of wiggle it, and if they're stuck, you know, you end up busting them. So if they're stuck, we're stuck. So it's another day, and well, what I decided to do, just for a giggle, and just because it was handy, so these seats just fold back, and you can access the fuel pump very easily. So there's the cover, and that's the iDTEC pump. So the plastic is for, there's a lot of dirt and debris there, so I'll give it a bit of a blow with the air gun. So the boot is clear in this car, unusually. So nothing there but a little dog hair. Very unusual. Normally when cars come in, you know, there's no fuel in them and the boot's full of junk. But anyway, We're going to monitor the current with the amp clamp, and we'll take it for a change. There's a bit of glare there. So that's the current clamp around the fuel pump. So not disconnecting anything, and you know, not doing anything invasive, just doing this just it makes shows up something, and there's a particular thing what I'm looking for, and we'll discuss that after a test drive. So a bit of a time in the screen, 1 second per division, and we'll run that and get the car up to temperature, see how she gets on. Right, so we're back. So I did a couple of runs, and yeah, the only reason why I'm doing this, I've done a couple of recordings, so a couple of runs. So the only reason why I'm doing this is because I'm not even disconnecting any pipes, and I'm just seeing if I can see anything here, you know. So I don't think that there's a problem, but what I'm looking for is, in case, because I've seen that amount of dirt in the fuel filter and stuff like that, is there maybe a fuel delivery issue because, you know, the sock, or there's dirt in the tank, you know what I mean? So is this fuel pump maybe struggling? And, you know, when you put it under load, then it can't deliver. Now, whenever the car failed on me, you know, the car started misfiring, I wasn't monitoring anything. I didn't have the scan tool. I was just driving it about. So unfortunately, I couldn't look at any data or anything like that. So I was just more interested in getting it home. So yeah, so very easily determine which is which on the plug, on the wee 4-pin plug in there, the electrical plug for the fuel pump. So done that with a test light and clamped around the appropriate wire, and just set this recording. So we'll get a wee look at that. So set a measuring value here at 5.5 amps, and we'll just go through it. There is I can see slight deviations here, slightly, but it's still. So what's that dip? So I'm getting a sort of rough average, 5.2. Now we'll just keep it there. We'll run through the pages here. 5.2. You know, so I'm not really seeing anything that's crazy. I'll just zoom out again. Just run through it. So it's all in around the 5.2 to 5.5 amps. And I've done it twice, as I said, so I'll open another one here. .something amps. There's a couple of wee dips, but it doesn't. It's pretty minimal. So, you know, so that could be attributed just to a slight voltage change. You know. So what I'm looking for here is if the pump was struggling to pick up the fuel in the tank. In other words, you know, there's a blockage on the sock or on the strainer, and it's you know, if it's all covered in dirt and debris, I would expect that current to dip off by 1 amp at least, or maybe 2 amps, you know, so it would dip away down, and that would tell me that there's a blockage, you know, in the tank. And then, you know, we would do a further visual inspection. But I'm not seeing that. It's not significant. To me, that isn't significant enough. You know? So it's more for part of the video here, just, you know, a wee test that you could do that's fairly quick and easy and simple without having to take anything apart, you know? So what I'm talking about here with regarding to the voltage dipping is, you know, if we basically unload a pump, you know, a motor spinning, the current drops. Now, that might sound a wee bit counterintuitive. You know, you'd think, well, if it was blocked, the motor would, you know, struggle. So you'd think the current would rise, but it doesn't. So the analogy that I use for this, what I'm getting at here, is a vacuum cleaner. And no, I'm not going to clean his boot out of his dog hair. So anyway, you can hear the motor changing. So whenever this is under normal load and there's no blockage here, you know what I mean? So what we're doing is simulate, this is easy to simulate a blockage. You know, so it's if the fuel pump had a blockage, you know, on the pickup, but this is simulating that dead easy, visually and audibly. So, but if we block it, we can hear the note changing. But that's what you're doing there, is you're unloading it then. You know, so the air coming in is normal load. When you block it, it actually unloads it. And when you unload it, it uses less current. And if a wee clip here, that'll demonstrate that. So you may think, we're talking about a fuel pump. This is a vacuum cleaner. What are we talking about? So what we're talking about, what I'm getting at here is we're talking about the electric motor, you know, just the motor. What the motor does is, you know, nearly irrelevant, but it's how it reacts, whether it's loaded and whether it's not loaded. And that is directly proportional. The mechanical loading, I mean, you know, the amount of work that the motor has to do. So whether it be fuel passing through it, sucking fuel up and pushing it out the other side, or in this case, sucking in air. So we can very, very easily restrict the airflow here by just putting my hand over the end of it. And we can see that in this ammeter here. So this is measuring the current draw off this vacuum cleaner. Now this wee meter here, it's a wee bit slow to react. It's an old cheap thing. It's designed to tell you, you know, how much an appliance is costing you. You know, you can set the cost, kilowatt hours and all. But the point here is loading and unloading of a motor with respect to, you know, getting it to do work, mechanical loading, and reflected in the current. So So 4.5 amps. Happy enough for that? So there's more current draw when the work is being done, and more current draw, 4.5 amps, whenever this is unrestricted. Whenever we restrict it, it's actually doing less work, so the air isn't being pulled in, so the current decreases. So we have another development. So after doing 2 runs with the Pico in the boot there, monitoring that low pressure pump current, car's driving great, know what I mean? On the report, and if we look at the live data, so the only thing that I was really going on here was the sort of smoking guns were the correction values of the injector 3 and 4. I thought they were high, you know, and the cylinder 4 misfire counter, which, if you remember the last time I took it a drive, I could see them, you know, just ramping up before my eyes, you know. Oh, there we go. starts counting misfires. And so it's today to do a S3 scan just to see if anything's changed, or because it's running dead on now. So what a difference another day makes. So let's see now. Engine coolant temperature sensor 88 degrees, and sensor 2 85 degrees. So that'll be the one in the engine, and that'll be the one in the radiator. So whenever they're much the same, it's just fully up to temperature. The water's coolant is flowing through. So let's see. So there's EGR position and position target. %. So I was never a concern anyway. But we're just looking at these numbers. Them, So again, real pressure target and real pressure. Seems to be following along, So if you're wondering why I keep I'm changing scan tools, a lot of guys do that, including myself, just to make sure one scan tool matches the other one. So I've had it before that, especially that snap-on sometimes tells you stuff that isn't correct, maybe lead you up a garden path. That's why we have multiple scan tools. Anyway, pressure and target, fine. But again, as Peter rightly said, if those were your problems, it wouldn't be limited to one cylinder. So it's definitely it's pointing towards an injector. He's 100% rate. Very experienced guy, but it's good to talk to somebody else. Just run it past them, just see what somebody else is thinking, put an idea in your head. But here's the main one that we was looking at. Injector 4 correction quantity 2.3. That has changed. That has now changed. So that was pegged 3, if you recall. Cylinder 3 still seems to be pegged to 3, but it is actually moving now slightly when I rev the engine. But 4 has changed to 2.1, 2.2. So it seems to be happier. Cylinder 4, there's 1.7. So that has changed quite a bit. And the misfire counters on 4, which seemed to be the problem all along, and it went too far. Where is it? Oh, hold on. Oh, by the way, in case I didn't mention it, so there's your energizing voltage, 100 odd volts. So that's why the guys test them at 100 volts. So that's I've seen people, I think, testing them at different voltages, but anyway, what am I doing? Misfire, where is it? Oh, I've got to, don't know where it is. Lost. That was right below where the quantities were. It was right there. Anyway, cylinder 4 misfire 0. So before, if you recall, that was going up. That was just ramping up before our very eyes. It was just misfiring. With every stroke, every ignition stroke. It was just going 1, 2, 3, 4, 5, 6, 7, just going right up. And I've done 2 drive cycles today. That hasn't changed. pegged at 0. So based on all that, based on those pieces of data, and this is all I'm going on really, and the leak off, as I said, is the leak back on the injectors was always, you know, fine in my eyes, you know. The leak off was good, so I've spoken to the customer again, and I've told him, right, the conditions seems to have changed again. This car seems to be all right now, so maybe, you know, with the cleaning fluid that I put in and, you know, a couple of heat cycles, it is cleared itself by the looks of things. And maybe there was a slight blockage in it, a slight bit of debris in the injector or something was making it malfunction, and that is now sort of cleared. It's cleared now by the looks of it. So the customer's going to come back and he's going to drive it, and maybe myself and himself, and we're going to go up that big hill again that I went up, and, you know, say to him, simulate the conditions where it actually broke down. So have it up the temperature, put it under as much load, you know, give it the boot, and see what happens. And he's going to do that, and I'm going to let him. What do you want to do then? So, but like, if it was me and the car's driving fine, then, you know, you're not going to fix what isn't broke. Working up a hill. This is the owner of the car driving it now, not me. Say hello, Paul. Hey, steady on now, steady on, don't go mad. You're on video now, speeding. You're not gonna say anything, no? It's not like you not to talk. They were catching up in the car ahead.
She's pulling like she should be pulling.
Ah.
You know, I'm only on third, but tell you what, I'll labour her a little in fourth.
There's a bit of a range there.
No problem.
No problem?
So far, so good.
So, in comparison to what it was like then, before we did anything? Night and day?
Yeah.
Right, so what do you think? Are we pulling the injectors out?
I hope not. I sincerely
Well, if it stays like this, then it's fine.
This is as good as ever driven.
As good as it's ever driven?
Yeah.
And that was all by changing a fuel filter and putting a bit of cleaning product in it and giving it a bit of a drive. Wasn't looking good at one time, but...
No, she's got plenty of, you know...
You alright appearing on camera?
Yeah, well, no choice to do. But no, here, and that's even... Like
it's a bumpy road, boy.
Yeah, but I'm in fourth gear there, and...
I mean,
I was in sixth gear there.
Got a maniac driving this car now.
Yeah, no, she is, I'll tell you what I'll do, I'll head on over the hill and come back up the hill again.
Well, that's grand, okay. Any changes, we'll turn the camera back on again. Well, after that vigorous test drive, it appears my hesitation in removing these injectors, it seems to pay it off this time, you know. So while the owner was in the garage, he tried to blow through this and couldn't blow through it. So normally the diesel comes in from the tank this way, and then that's the outlet. But blowing through it this way, you can't actually blow through it. That's how blocked it is. So all this was because of a fuel filter. It's just water. I'm just going to show you. Maybe we can see something here. Not really coming out. Kind of blocked. When you see stuff like this, you know, it makes you wonder, how is this car even run? They're starting to come out now. So you can see this, the filter sort of bulging as I pump it up. So yeah, we'll talk about diesel bug, you know, bacteria that forms in the diesel and all that there, Carol. But that hasn't been changed in an awful long time. And this stuff, well, was this the magic cure? Diesel purge? Like Molly? Don't know. You know, it's bound to have helped, but you know, the first startups that it did, it would have been running on this, you know. So the fuel filter housing, I filled it with that, you know, and then the return goes directly back to the tank. You know, it doesn't go into the ear. So it would have been running purely on this stuff, nothing else, until, you know, the diesel from the tank was pumped into that, and it would have probably mixed or whatever. But yeah, a lot of heat cycles. I think the heat was the key. It seemed it would fail on the heat because, you know, the tolerances and the injectors, you know, expand and all that, I'll carry on. But it seemed that number 4 seemed to come back to life after a few drive cycles. So there you go. Yeah, save the customer quite a bit of money. You know, it's over for 4 injectors for that thing would be well over £1,000. And then you have to pay for fitting. Fitting isn't free. But anyway, maybe you get something out of that. And many thanks for watching, as ever, and all the best. And give us a bye.